Alright, this is on laws of exponents. And I'm basically going to be going over the top part of the worksheet you got and doing a couple of examples. The laws of exponents, where it says to complete each law, the first one, a to the m times a to the m, is we're multiplying exponential terms with like bases. When we do that, we add the exponents. So, example, if I had 3 to the 4th power times 3 to the 5th power, that becomes 3 to the 9th power. Now, that second one, a to the m power, all of that raised to the m power. When we raise a power by a power, we multiply the exponents. Nice example here. Oh, how about 3 to the 4th times 3 to the 5th? That becomes 3 to the 20th power. Alright, now, law number 3 there, anything to the 0 power is 1. Example, if I had 248,269 raised to the 0 power, that would equal 1. Now the fourth one, kind of interesting, a to the negative n, right? I can move the base to the other side of the division bar and my exponent becomes positive. I can think of that as a to the negative n over 1. That becomes 1 over a to the n. Right? If I had 3 to the negative 4th power, that equals 1 over 3 to the 4th power. Oh, and it's time to go home on Wednesday. Number 5 is a to the n over a to the m. Well, when we divide exponential terms with like bases, we subtract the exponents. Example here, 3 to the 5th divided by 3 to the 4th is 3 to the 5 minus 4, which is just 3. Alright. The sixth one, very similar to number 4. If I have 1 over a to the positive n, I can move that to the other side of the division bar and the exponent becomes negative. This becomes very handy in differential and integral calculus, I can tell you that much. Just know that it exists. Example, 1 over 3 to the 4th power is equal to 3 to the negative 4th power. Alright, let's see. The seventh one.
May your attention, Peg still has one pasta dish that's left in her room. If whomever brought it could come and grab it, that would be great. And have a great Thanksgiving, everyone.
Just like Amy said, have a great Thanksgiving. AB raised to the n power. Well, what we can do is we can think about a and b being raised to the first power and then distributing the n on that. That becomes a to the n, b to the n. So let's say I had 3 times n, and that was raised to the m power. Nice little example here. Well, that becomes 3 to the m times n to the m power. Alright. And last but not least, that eighth one, where it's a over b raised to the n power. This is very similar to number 7. And think about a and b being raised to the first power, and I distribute the n onto both. It becomes a to the n over b to the n. So if I had, I don't know, how about 4 over 5 to the 3rd power? That becomes 4 to the 3rd power over 5 to the 3rd power. Okay. Alright, now let's take a look at one nice little example. Let's take a look at something like 2x cubed y squared, all of that to the 4th power, and that's all going to be over, oh, I don't know, how about 8x to the negative 2 y cubed. Okay. Well, the first thing I'm going to do with this is I'm going to distribute that exponent 4 onto everything in the numerator. That becomes 2 to the 4th, x to the cubed to the 4th power is x to the 12th, y squared to the 4th power is y to the 8th, and that's all over 8 x to the negative 2 y to the 3rd. Okay, now 2 to the 4th power is 16, and I'm going to write that over 8. And then I'm going to go x to the 12, and I'm dividing that by x to the negative 2, so I'm going to go minus negative 2. And then I've got y to the 8th power, and I'm dividing that by y cubed, so I've really got 8, then minus the 3rd power. And that's all going to equal 16 divided by 8, commonly referred to as 2. X to the 12th minus negative 2 is x to the 14th, y to the 5th. Alright, and this concludes our video for today. Thank you.